Hi, today I have something completely different, for me at least. This is a DJ mixer from Alan and Heath, an Xone 92. It's actually already, I believe it's from 2004, so it's not the newest thing. Seen some use, was bought second hand, and recently the filters, there's two analog filters, multi-mode, low pass, band pass, high pass, and first one stopped working and then the other stopped working. And well, you think it's a DJ mixer, how complex can one of these things be? It's actually quite a sophisticated device, and I've been troubleshooting already, but it was actually quite difficult to get to the parts where everything is happening. So what I did, disassembled the entire device, and it's actually much bigger than what I usually have on the bench. And as you can see, it's a modular design. It's actually quite nice. This board here is like a matrix and power distribution board. One big ground plane which gets screwed to each daughter board. And these are 4 channels. Some summing and grouping and routing, and there's obviously an output board, and this is one of the filters. And what I wanted to do is to make measurements while it is out of the case. So these are normally connected internally on the matrix board, and I just made a jumper cable so that I could hook it up, lay it down, and then there's one more thing. That's to there's no ground connection on this wire, so I just clamp, how do you call this in English, a crocodile clamp, and connect it to the ground connector. So this enabled me to do some measurements on the board while the power is on. And well, the filter is sort of working, but only for a fraction of the range, and actually the low pass only. So it could be a lot of things on this board. There are some chips on here that are not available anymore, and yeah, it's a quite complicated analog filter. But what I did notice first was power supply with some bulgy caps, and it's actually buzzing quite loudly when you take it out of the case. So there's some scorch marks on the bottom side. This part, it's a switching regulator, because it's switch mode power supply. It's still working, the voltages are alright, but it's quite high ripple. So I'm going to suggest recapping the entire power supply, see if that improves anything. There's also, let me show you. There's also a metal case on here, and you can imagine that all the heat from the switching gets trapped in here, and all these caps are there together. I still don't get it why you put caps on a place where it's gonna get warm. Just put them somewhere else. And these are Samoa brands. Not the worst, but not the best either. And then there's this board. There's 2 of these, one with a dedicated MIDI input, because you can control the filter by MIDI, which is actually really nice. But there's a few transistors and JFETs over here, and some of these get really, really hot. So did they fail? I'm not sure. I'm gonna order some replacement parts. Some are not available anymore, but you can get a substitute. And see if we can get it working from there. So what I did, I installed the second filter this is the first filter, because I have a feeling that the filters are routed internally. There's like a bus going through the second filter when you use the first one. So I want to be absolutely sure that this is the only part that I'm testing. My device on the test, as they would say. So the power is off. I'm going to connect the signals. Yes, and then connect the ground together. Now if I power it up, I can already hear the buzzing of the power supply when it powers up. Right, so some of this stuff is getting smoking hot. Like these transistors here, Q10, which is for the left channel, and Q6 is for the right channel, but only Q10 is getting really hot. But the question is obviously, is the transistor faulty or something else in the circuit which is draining just way too much power? So I made some progress in the meantime. Today I received some components, and this should be enough to at least repair the power supply unit. The PSU is there's a lot of ripple on the PSU, and I'm gonna take it out and recap the entire thing. I even took the SMD caps as precaution, because there's a faint buzzing, and I had broken multi-layer ceramic capacitors before that were like oscillating, like vibrating, audible. So I'm gonna replace every capacitor on this board. And by the way, this cap is not something to be taken lightly. It can really cause serious harm, obviously. I looked at the caps in circuit, and they don't seem too bad. There's only the one big 68 microfarads 400 volt cap, which is a little bulged, but if I measure the ripple coming out of the connector, which is powering the mixer, it's over half a volt, so it's too much for my taste. And well, I've seen some serious use, and the date code, well, it's over 10 years old. So, and these are somewhat caps. They're not bad, but they're also not good. They're pretty average. And I bought some Panasonic and Nichicon and United Chemical caps to replace everything, which is obviously much better quality, and hopefully will extend the lifetime of this mixer with another 10, at least 10 years, but maybe 15. At least regarding the power supply. Even with this tool, it definitely helps to put the circuit board against a light, because legs that are connected to a big ground plane, they really do need a lot of heat before the solder melts and before you can suck it out. And it can look like the leg is already desoldered, but then on the other side it's actually still attached to the big ground plane, or a big trace for that matter. And especially on power boards, they they don't have the thermal reliefs. If you have ever designed a circuit board with software, with CAD software, they have these small connectors where the lead connects to the ground plane, so that when you solder it, it doesn't suck up all the heat. And this helps to concentrate the heat on the lead and not heating the entire ground plane. But on power boards, they very often leave the thermal pads off because, well, the trays get smaller if you use thermal relief connectors on your leads. So on one hand they're much more sturdy to work with, but on the other hand they're also they need a little bit more power. So I'm going to change the nozzle, take the big one off. This needs to cool down first. Now what I recently found out is that I used to, oh, I can do it again, I like to test these capacitors when I remove them from circuit. And then very often, let me give it a try. Very often, so the ESR is low, so that should be a good sign. And it says, well, 10 microfarads, so it's within spec. So you would guess this capacitor is probably alright. But the thing is, this device is using a very low voltage to test this capacitor. But things seem to change. This is a 400 volt capacitor. It could very well be that if you load it up to 400 volts, that it gets a completely different behavior. And that is actually not within spec anymore. Yeah, low ESR. Yeah, they all seem within spec. Still, this board is rippling like whatever, ripples a lot. So I'm gonna replace all these and then do some measurements again on the oscilloscope to see if the ripple improved at all, or maybe it's just supposed to ripple like that and it's just part of the design. But that would surprise me actually. But hey, what do I know? So this is how I remove my SMD capacitors. Put some flux in there. Heat up the air gun. And I've marked the capacitors that I want to remove. Here, let me see if I can get this closer. And there's the two small, I believe 100 nanofarads. And it wouldn't be the first time that these actually fail on me, and but not in a fatal way, but they start to resonate. They maybe become more of like a resistor. I'm not sure. And I've had regulators that became really hot because it was just sort of short to ground. And I will burn up the sticker, but yeah, I think I can't help it. There we go. I'm not gonna bother for this one because this isn't just in the. It's unimportant where it is. Even if it would fail. I'm gonna clean this up. I actually saw when I was looking on the magnifier, I saw what could be described as some water liquid damage. So I'm gonna clean it up here. So sticky flux now. But the flux actually helps to. You can even put on some flux and then reflow with your soldering iron. This will actually burn any debris that's on there. Normally I do this under the microscope, but for now yeah, let's get some alcohol and clean it up. This is the shit, by the way. The MTech Techie Flux, and I bought this from TME, or yeah, this the one who supplies the real deal in Europe, because you can get this in the United States, but don't buy it from Amazon, don't buy it from eBay, because there's a lot of knockoffs. I think this is the real deal. There it is. It's a snap-in type, and I wasn't sure, so I bought two versions: with the standard leads and the snap-in type. I'm not sure why you would use one over the other. No clue. And I'm really curious to see what this tells us. It should be 68 microfarads. Well, the specs say it's actually really good. Really low ESR, 0.3 ohms, within the spec of the farads. But yeah, this is a 400 volt capacitor, and it's bulgy on the top, and I'm not sure if that's the type of packaging or that it's actually like a little bit swollen. Oh, that looks nice to me. Nice and clean. Ready for some new caps. There's no real way of showing you this. I have my microscope set up here. One thing I do is there's unleaded solder on the board now, and I want to use my own leaded solder to replace the new components. So I put some flux on the board, take some nice quality wick, and first what I'm going to do is take off the old solder and then apply some of my own, and then reinsert the components. So I just replaced all the surface mount components, and yeah, you can really tell, but they're here and all looks well. Give it a little cleanup before I solder the big capacitors in, and I did have a look under the microscope as well to see if I could find any solder cracks, but it actually looks quite right. Even the connector looks alright. This part of the board gets really hot, as you can see on the bottom, and sometimes this can lead to cracks in the solder because of the expansion from the heat and heating up, cooling down, and then in the end can create cracks. And it's for the final capacitor now, the big 400 volt unit, and I have two exactly the same. This is with regular leads and nice Michigan example. Would it fit? Probably. Yes, this would be no problem. I just wasn't sure because I didn't want to take it out before I start ordering. This is a snap-in type. I believe this is also a Nichicon. They're exactly the same ratings, 68 microfarads by 400 volts, but you can see the snap-in type is a lower profile. The diameter, the snap-in type is a little wider. But yeah, this feels nice, sturdy. Looks good to me. Enough clearance. It's an upgrade anyway. So let's take it in. Well, that's it. I'm gonna give it a final inspection and then put on some power. So here it is. I did a complete inspection visually. I have the power plugged in. It's not grounded. This is obviously a dangerous step. I have the power switch right next to me. With stuff like this, I tend to wear my goggles because all these capacitors they could potentially blow. I could have made a mistake, wrong value, wrong whatever. These things can blow, go up in smoke, and we don't want that. So I have an extinguisher always right by my side, and I put up my goggles, And well, let's turn on the power. Well, I don't hear anything, so let's see if we can get a voltage. This is the plus 15 rail, and it tells me 14 volts. Okay, and it's minus 15, 14.9. So it's actually a little bit uneven. I do have replacements for these. Maybe I will swap them for some fresh ones. But I'm really curious now to see what the ripple is like. So that's next. Well, that was actually quite scary in the beginning, because I was measuring over a volt of peak-to-peak ripple on the power lines. So I thought, oh, I've done something completely wrong. But then I forgot, oh, you have to set the bandwidth limit of your scope to 20 megahertz, I believe it is. Yeah, 20 megahertz. And the last time that I did this measurements, I had my high-res Acquirey or whatever, and so I set up the scope in the same way, and now I'm measuring a much lower ripple. It's still, I still think it's on the high side for my taste. I measure 300 millivolts AC ripple on each of these power lines. This is the plus 15 volts. It's like it's actually quite steady ripple, and on this rail I believe it's a little bit more. Yeah, 320, 340 millivolts, and it's a little less stable. Yeah, it's between 300 and 340. It's actually quite fluctuating. And on the other power line, the plus rail, I actually measure quite a steady frequency, the switching frequency, because that's what I see. I just see the switching frequency right here. But on this rail it's fluctuating between 13 and 27 kilohertz. And if I switch to this one, it tells me, oh no, it's just as weird. Yeah, it's actually quite 13.3 kilohertz, and I'm no expert at all, but to me that sounds like a reasonable switching frequency for a supply like this. Maybe first I'll check how this behaves in the mixer, and if there's still strange and weird stuff going on, then I can always swap out these two voltage regulators if necessary. And until then I'll probably keep it like this. So then there's this board. This board is the matrix distribution board, you could call it. It's also available for power and connecting all the grounds, as this would look. All the cartridges that make up the mixer, like the filter section, channel section, these are all like strips and cartridges slots. You have a screw on top of here which connects all these cards together. And this is actually on the bottom of the mixer. The cards are standing upright on here and the controls are here. And you can clearly see there's a lot of I'm not sure if it's a coating or that it's like a buildup of something, oxidation. I'm gonna give it a scrub so that these contacts, or that they make more contact. So I have a bit of dioxide here. I'm gonna try it on this one. It doesn't seem to come off in any way. But I do feel that it's something that came on here afterwards, because you can actually see the imprint of the mounting post on the card. It doesn't seem to come off at all. This is just a regular deoxide D5. I'm absolutely not sure what it is. It's a bit scratchy. Yeah, it's really hard to see. It looks like it is improving a bit. If you compare this piece with this piece, yeah, it does seem to work. I only want to clean the unnecessary parts where the mounting post connects to the board. You can clearly see that the difference, this part is upside down in the mixer. And there's like a world of difference with this side, which does make me expect it's residue, maybe from smoke machines, maybe from liquids, maybe, well, who knows, I don't. Here's another example of the ground plane, the big ground plane, screwing it up because it sucks all the heat away from the part that you actually want to desolder. What I sometimes do, which can help me a lot, is just apply some unleaded tin, because the melting temperature is much lower, and then let it sink in. Now we'll try it again. It's much better. There it is. There's marking on the board. I actually think originally they used one of these. Look at this. It's actually a perfect match. But maybe they found out that it was unreliable. And it's actually the power connector coming in here. So what we could do, because I've also got one of these which clamps it down, but I can already see a problem. There's no room for the mounting post to go. Let me put this in place. So I think it will just have to be this one, and maybe I'll use some hot glue to make the connection a little bit more permanent. I actually think very often that that's quite a reasonable solution. Make sure it's nice and flat. Yeah, it's good. So I made a temporary jumper cable to test my connection here. See if it's not reversed, because some of these things will blow up probably if it's in reverse. There's also a 5-volt regulator here which we can test, and we can also test transfer of the power rails here. So let me turn it on. Oh, looks good. And if I measure pin 1 here, I get over 15 volts, so that's the plus rail. And on pin 2 I get almost minus 15. It's a little bit out, but there's no way to compensate, there's no way to regulate this. And there's also a 10 volt rail coming from the power supply unit, which connects to here, and it's a steady 10. And there's a 5 volt rail coming out of here, and it's a steady 5. So, well, this looks good. So I have everything back here. All these flat cables are new, and I'm already preparing the heat gun because I want to give it a try now, see if it fires up, if everything works as expected. I cleaned all the contacts, did whatever I could. Yeah, there's nothing else that I can think of now. I made a new connector on here, cleaned all these up. Now it's time to put it back together. And yeah, see what happens. The original problem was that the filters were not working. With more testing I also found out that yeah, it was really scratchy at moments, but not all the time. Like you would hear a thump when you push the fader all the way up. Stuff like that. May seem a bit silly, but I actually have this shrinker wrapper plier to crimp IDC connectors. They sit in firmly, and you can press in the forces spread out evenly. It wasn't expensive at all, and I'm glad I have it. And also, which I really like, and maybe I've made a video about for this, and well, my adapter lead is a bit short, so but you can it's a Eurorack thing where you use 10 pin and 16 pin connectors, so in this case, and if only I would have power right now, you press a button and you can see which lines are connected or if they're shorted. This one is fine. Much better. This is the one for the power supply. This is the mic input for the back, and here's all the EO. And this one is especially prone to problems because it gets tangled up. It's actually the original version. Looks like this, with some tape around it. If you can see here, well, these are all potential problems. So it's stuff like this that makes me think, well, even though it's an environmentally friendly product. Okay, whatever. So let me get the backboard out, screw this on, and bring the power supply here. Included was just this how do you call this? A Fast-on connector, but there's actually no scratching ring underneath, which I don't like, because you should use one of these to make sure you really get in contact with the case, and then one of these, and then I always like to put, well, a metal ring on top. Now it's much more of a connection that really scratches into the metal, and even though it's not painted, well, I just like it better that way, and it will never come loose. So I just gave it a spin and everything works again. The filters are operational, and I think it was mostly to do with the flat cables, reseating, replacing them, and I think this unit is good for another 10 years or so. Yeah, should do it. I do gonna put some hot glue on some of the connectors just to make sure they don't fall out. I'm gonna play around with it to make absolutely sure that everything is in working order, and give it a clean, and then give it back. Thanks for watching, and see you later.